Hello, everyone. Welcome to my session on data-driven innovation. My name is Christian. I represent Valya, and I'll take you through our perspective on data-driven innovation and how that plays into the current state things. So my name is Christian. I'm the CTO and co-founder of Valya. We work with innovation and data. Pretty relevant perspective when you're coming into this. And to give the foundation of my perspective, the way I work, I have a scientific approach to things. I base that on agile development, and it's kind of those two that goes together. You'll see a lot of the scientific method, the approach there, tied together with the agile development. I have a favorite saying, Nullius in Verba, the Royal Society, talks about the idea of take nobody's word for it. The case here is if you can't test it, it's not true, and at least it needs to be a hypothesis that you base your findings on. It's not an academic session. I'll have foundations in practices. There's, of course, a lot of elements here that play in the agile development, the Scrum, and of course, the scientific method is by itself academic. But all of this is from the perspective on how we apply that to our work within innovation and how data-driven innovation can be applied for you. So it's free form, it's personal experience, preferences, and of course, in relation to where I come from, Valya, it's the methodology that we follow, it's what we advocate, and it's how we approach all of this, both in how we build internal processes and how we try to approach the market with that. So table of content, I'll start by setting the stage when I get into that. We'll talk about the unknowns, I'll talk about growth, how that plays in together. We'll have its angle for innovation. Then we'll look into infrastructure, how would you approach the whole data innovation? What's the decisions to make there? What's the best approach? Is there a best approach? A little bit in the foundation of what we've done, but hopefully something that takeaways on how to approach innovation and data science in that collaboration. And of course, the approach. I say here, and what I mentioned earlier, agile meets data science, and that's what this whole will center around. It's the idea that you'll have an iterative process and the hypothesis-driven, let's figure something out, let's explore it, which goes together and becomes that foundational approach where you go from hypothesis into iteration and hopefully, as I say below, go from theory to strategy. The outcome is obviously when we talk about innovation or any of these processes that you can apply to your strategy and cooperation, hopefully also acting on that. I'll then end on a little bit of ethics. It's not going to be as it sounds. It's how we see and I see the future of data and transparency, how that plays into these processes, how you treat data and how you work with innovation in that perspective or any other data science processes. And of course, the distilled version, the conclusions and summaries is for anyone who want to skip to the end, that's probably going to be the main elements. So unknown unknowns, my first talking point. I call this the categorization dilemma. That's a lot of what we work with. It's kind of the idea, I say, the chicken and the egg of innovation. It's a little bit approaching the area of saying, well, if we haven't categorized something, if we are not in innovation in a way of saying, well, this is what I need, or this certain category, well, we could talk about in as an example, the area of IoT that's pretty relevant for this. Well, if we haven't tagged something or tied a certain technology company or innovation to a certain sector or keyword or technology, then how do we know what it is? It kind of needs to be categorized before we can work with it, but we also can't work with it without it being categorized. So how do you find it? That's a little bit of the dilemma, and that's where we see the data-driven approach, data science, that hypothesis-driven approach being relevant. And then that ties into, is anyone really aware of what they don't know? It's not philosophy. It's not where we're going to go here, but it's kind of the approach of saying, well, if you're not aware of something, or if you're not aware of these unknown unknowns, the area where you don't know what you don't know, then it's going to be really hard to work with that. And we have confirmation bias. From my perspective, it's one of the dangerous human traits, especially when we talk data and then this structured approach. There's a monkey brain that will try to help us do the quickest, most efficient approach that works very well on the savannah, but it works less well when we work with large amounts of data. So we may classify something quicker than necessary, and we might end up in a direction that's the familiarity, what we're used to, but not what we actually should. And of course, we look at objectivity, and that's without losing direction. When we become really objective, we tend to slow down. And that's where the confirmation bias tend to help us when we need to make a quick decision. So we need to balance these two. Growth opportunities, kind of the unknowns. We'll talk about, as a innovation. Other than a buzzword, it's risky. That's what we do. We take a chance. And where this plays in with the data approach, the validation is, well, let's minimize that risk. Let's not bet on everything, but take a hypothesis, run it through, and say, where do we go from there? I talk about first movers here. It's a little bit like you may not need to be the first mover for a given technology overall. But the idea is if you can cut down one unknown and say, I want technology X, we need to apply blockchain, but in our area, then we've already narrowed it down and we can use that blockchain as the hypothesis to become the first mover in your industry, not necessarily all over. And there's different ways of achieving growth. The product life cycle, that's an interesting way of looking at it. There are first movers, there's the whole adoption, it grows, and then at some point you'll be at an area where that is explored. And that entire area is where you can jump in and take, maybe it's also seen, it could be reverse correlated with risk and say, the further you go, the more certain it is, you jump in, but of course, the less of a gain in there. And then where does data come into the picture? Well, I see it as minimizing the risk. It's the idea of saying, well, can we have fewer variables by identifying some of the other ones and then work with a couple approaching it like that. The building blocks for this, and we may become a little bit technical here, but that's very much from the way we see if you want to approach innovation or any decision point on the basis of this, it's having these foundations set down, the building blocks of your infrastructure. So we talk a lot about data. Data is going to be a very important element all the way through this, but the data sources, the primary and secondary sources, a little bit the decision of saying, well, am I good with something that's already been identified, or do I need primary sources that are exactly defined based on what I'm looking into? Is it the known problem? It's a known classification? Is it social media behavior or questionnaires that's done 100 times over? Then secondary sources, probably great. But in terms of primary, I'm working with something new, a consumer behavior directly in our area, and we might have to treat that as this is where we need to find the primary data, actually develop it ourselves. And then the foundation, well, we can work with the sample set and we can work with the static or dynamic data. And that's where we may see the clashing between the agile and the data science. It's a little bit of the idea that, well, maybe a sample set and a static data set is enough. Maybe we test a hypothesis, we run that on a greater population, and that's it. It's very foundational statistics here. Or we need something where it constantly evolves. We have a product launch, something goes out into the market, and that's where the dynamic data becomes very important. It's a little bit of saying, well, we change every week, so we need the data set to follow along. We need to see those behaviors in the market. And that's just getting considerations on how to approach that. In terms of infrastructure, now we're talking about we have a data, now we need something to process it. We need a database, we need some data inflows, we need the processing of that, and maybe even some algorithms. Do we make that or buy it? That's a good question. I would say always buy whatever is standardized. It's a little bit the idea of there's no need to build something that everybody has as a commodity. We have cloud services and servers and all over the world. A lot of companies out there do that a lot better than anyone, better than us, obviously. So that's the case where we buy. And then, of course, if we can minimize the amount where we make, which is the unique element where we need to do something specific, maybe it's tuning that algorithm, maybe it's sourcing data in a specific way, processing or classifying, then that's where to focus. And then on the other element, the monolith versus microservices. It's kind of the case where we can build a very efficient one program that does whatever it's designed to from the beginning very well. But as soon as you change one thing in it, it breaks down, it fails. That's an operating system. Or we look at microservices, what we use in this approach, and that's very much based on the fact that we don't know where we're going. We know we'll have some elements, some very important key stake parts. There's a database, there's some processing, there's a sourcing element. So those become each microservices and they talk together. It's a little more expensive, heavier to run. It requires a server and a processor for each of them. but you can pull out the algorithm, change it out, or add an API connection wherever you see fit, and it will still run as long as you follow the same communication pathways. There's nothing right here. I think the general movement is towards microservices with the much lower cost of hosting and processing. But it's just something to keep in mind. It's very hard to change down the line when you have a big monolith that does one thing very well, and suddenly your market changes, so your approach needs to change. Then looking into the processing, there's multiple ways of approaching that. And I write this, I say AI, machine learning, statistics, gut feelings, and other synonyms. And it's kind of true. When we start this whole process, and I get to that a little bit with the data science, that way of working with the hypothesis, you actually use your gut feeling, your human, pattern recognition and approach to say, well, is there something here? Of course, when you start working with a large data set, very complex, or you actually don't know what you're going to look for, if you need unsupervised learning, that ties to some of the other elements, the machine learning, the artificial intelligence, or statistics, which is a very proven approach. But of course, depending on what your outcome is, again, something to consider in the beginning if you can, or at least have a setup, an infrastructure that can adjust and fit. Well, let me look a little bit about the data, the sources, and the enrichment. We have a large focus on that, and that's very much based on the idea that without data and good data, you have nothing, or at least you have very little. So where to get the data, what data to get? Some, as we said earlier, can be primary deciding factor. It could be something where this specific parameter is actually the outcome we're looking for. That's very easy to measure. Or others is, some parameters lead to a specific area. Some areas can be deducted or, used to then infer this is the outcome that it leads to. If we look into some classification situations, whether or not it's a cat or a dog or whatever, you may not know from a picture when you get that if it's a cat or a dog. Maybe it's not in the picture, but certain pixels, a tail, and ears, how that look may actually determine that. So that's kind of saying, okay, what are the data points we need to determine what we're looking for? Is the same that we are determining based on the outcome, or is there two different things? And then that helps identify the sources. Then the enrichment process, sometimes you need to process this data and say, well, we need a sub-processing element. And then how to decide on the validity. Here it's test and iterations. You don't really know. Sometimes data can come from a great source, but you may not always know what the validity is from the source, but also in your application. So that's where we at least recommend testing this. Set up a simple hypothesis, something that you would, by your gut feeling, your human processing would say this is a given. These two parameters must give another element, and then test that. A good way to explore the data. Of course, the importance of structured data depends a little bit on how you approach it. If you're looking into some supervised learning or using specific parameters to classify, that's more needed. If it's unsupervised learning, you may get away with a different setup. But yeah, quality of data. Yeah, when we know it's good enough, that's hard to tell, but that's something to again keep in mind. And for our point of view, or from the point of view, I would say it works very much with the significance you're going for. Are you actually in the point where you need a very high degree of certainty or a very good significance? If you're working with medical data, I mean, obviously that's some of the areas where you need an extreme degree of certainty, then the quality of the data helps. Empty fields doesn't work well with this. Or on the other side, if you're doing an explorative approach, maybe it's not that important, at least at that stage. And then enriching data, that's something not to forget. Both machines, processing neural networks, going through and saying, well, how can we determine a country based on the description of a company, or technology based on a pattern description, all that stuff, or humans simply classifying it. That is a important element very early on a lot of things, and that human classification can also help on later stages. It's not, out of coincidence that we call it artificial intelligence and base that on human intelligence. It is the point that, sometimes we need the humans to do the first step, the first hard grunt work. So now into that question, if we remove the element of the gut feeling, I don't think that needs much explaining, but if we look into statistics or machine learning, that's two different schools, but they share a lot of commonalities. It's the question, what's most appropriate for your use case, so to figure out when you have the data and we have the hypothesis. But what I would say is for the models, choosing the models, simple regression, you can do that with both. Is a very good start for anything. Can you do a regression, a linear regression even, that says, is there correlation between what we're here to test, maybe on a sample set? It makes sense for everyone. Everybody can look at a graph and a plot and a line and say, yes, there's something here, and let's dive in. Obviously, that's not going to be the model we put into production. It's not going to be what we work with, but it's something that gives a good start and it validates. Again, this testing and this iteration is so important. Otherwise, you spend half a year and you're down the line and you have an overfitted model that does, nothing else than describe your samples data perfectly, and that's sad. And then, of course, the approach and outcome, and that's where we talk about the statistics and machine learning. Are you looking more at determining these parameters, if they together were to define something, kind of the elements of the model, or are you looking at the outcome and you don't really care? I'll talk about black boxing at a later stage of the black box, and that's where machine learning have its pitfall, but also the strength, where you can use a neural network or some clustering or random forest and all these fancy names for algorithms, basically saying, machine, please figure out where we're going. Tell me what this is, what the outcome is, and I'll trust you blindly. That's not very comforting. It's hard for a lot of people to approach that, but that is sometimes the case. I mean, if we look at a self-driving car or identifying pictures, it becomes so complicated through neural networks that it's impossible for humans to say, why did it do this here? I mean, we can try and backwards engineer that, but that's not always the case. And then how to pick? Well, the other question is, yes, you can change your mind, looking back into the structure or the infrastructure. If you design so that you can learn something new later on, then that's actually something to keep in mind. Maybe start by doing some data science and testing, and then putting that into production where you're more certain later on. Talking about applying the models, data is key. It's good data can make any model good. It's often the simplest models that work well. We use K nearest neighbor, very simple unsupervised learning that does a lot of very important work for us, and that's known in a lot of other instances. That if you have the right data, if you apply that and use it, do your testing, then you can actually use very simple light models to do a lot of impressive work. And then on the flip side, choosing the algorithms, a simple model, again, and a complicated model might be necessary, but sometimes there's a very low gain in the end. So just using the most fancy sounding deep learning model out there might not be the right thing to do. Of course, depends on application, all that stuff. There was a very famous, or at least a time when Netflix posted a challenge to say, hey, could you design a model that recommends users what to watch next? And I think there was $1 million in the price. And someone did a really good model, very, very heavy, expensive to run. And they got the money, but it was never implemented because it was unrealistic to run that every time someone watched a movie. So there's something of the case to think in here. Sometimes a simple model can go 95% of the way for 10% of the cost. That's also something to evaluate. If we're looking at training, getting that feedback, having that loop running, it's so key to all of this. You may choose a model you may be able to run. A lot of the modern programs and processes of running multiple models at the same time makes it very easy to test and decide. But it's so important to have that feedback in so you can go back and change. And then the black box, when is transparency a must? And if it is, you need to take that into consideration. As again, a neural network that can do a lot of impressive stuff, but there's a lot of little boxes that work together to decide. It basically works, like neurons in your brain. Very hard to describe. So if you are looking to categorize credit scores, where you actually need to provide that transparency, you're probably going to have a lot of work to then make it transparent afterwards, backwards engineering on that. So that's a decision point. And then optimization, can a model be complete? They'll never be complete because then you overfitted your model to your sample set and it won't work with a new sample set or new data point. So that's just, it's a constant training or, that iteration process. And then the scientific approach, it maybe becomes a little, how do we play that into this? But the idea here is that this, all academics have at least had a familiarity with this, but if we apply that to this setting, we apply that to data-driven innovation or working with data science, it starts with the business. It starts with a case or question or hypothesis, and then we move forward. Of course, sometimes we have some data scientists tinkering, come up with something interesting, but it needs that connection to the question in the business. Can we use it? Could we classify something? Can we predict behavior? All this stuff. And that's the hypothesis that feeds in. And that's where I add, can I prove it wrong? And that's such an important statement to remember. All good science, all good models has a very clear way of being proven wrong. It's not, I make sure my model is right. It's looking at it and saying, well, can this model be proven wrong? And if everybody has a chance to do that and it's not proven wrong, then I'm in a good place. Then my model is at least not wrong. It's right until it's proven wrong, right? That's important to keep in mind. And then, of course, the data, requirements and collection. Where do you get it from? What data do you need? And then understanding and preparation, putting that up into a setup and having that running. And then the modeling, feedback, putting it in production, see if it can work, maybe start with a sample set and then scaling it up. And innovation and evaluation and deployment. And that never stops. And that is where, if we look at the approach, like how do you actually approach and treat a result? There needs to be some kind of significance, and that needs to be defined before, because it's very easy to sitting here with an output or result and saying, hey, great, we got some kind of certainty. But if you haven't put down in the beginning, we need X amount of certainty, we need some kind of significance so that we, have where we prove it right or wrong, then we, again, as monkey brains, I mentioned earlier, we have a tendency that's easier for us. We don't have to do it again. So maybe we'll just, this was right. It was close enough. But that's important to have that hypothesis. And of course, being careful of any false positives or negatives, but keep that in mind. Sometimes that shows up. Sometimes it's not okay to conclude. It's actually a result not to conclude anything. Like overfitting, as I mentioned a couple of times, you can make a model that fits your sample set perfectly, but any new data point, then it won't fit. And then no result is actually a result. Sometimes there's just no significance and we should move on, or we should reiterate, adjust the hypothesis, let's try another algorithm, maybe. But every time you try a new algorithm, that actually also works into those false positives. Evaluation and feedback, again, iterations, that's a key. Make sure that goes in an iterative process. And then what I call agile science. The agile development, as most people are familiar with, working in those iterations, avoiding the waterfall development process. It's not necessarily the same as the academic approach or the scientific approach. I call this, the academic cycle. It goes from start to finish. We have an hypothesis. We work with a static data set, and we iterate over that. We get a really good model, and we explain that away in a very complicated scientific paper, and then we're done. That's not how agile, as I say, madness works. It's iterations. We're never done. If we're done, we did it wrong. And then there's a sweet spot between the two, because especially the data science team I work with, they need the time for the tinkering. It's not something that's just done in 2 weeks, but also when you give, an academic mindset the full freedom, it may take 2 years because it wants to be done perfect. And that's also not the case. And all right, business becomes science and back again. It's kind of that process. If we can make those two things work together, if we can have a business hypothesis, we can run that through the scientific process and then back into an application, maybe even have that as a larger feedback loop or together with the agile process that runs those iterations, then we have a really good setup that can achieve a lot of things. This can be applied to a lot, but we do this with the innovation approach, and it's kind of where this is targeted at. But any software development with science, data science is a part of it. This is the key. It's not easy, but it's good. And then, we share a hypothesis perspective. It's like both agile and data science, they need that hypothesis to test. And that's where they have to come analysis. That's where they start and work from. So data-driven strategy is pretty important. We may find some very concrete solutions, but what we do with that. And that's it's an input and it's a structured process. We kind of need to carry over the data science or that approach into strategy if we're following that. I think I write the bit bottom there, don't fall victim for personal preferences, and that can be a case. Sometimes some really intelligent people have some really good gut feelings, but if we're running the whole data science process, if we're running that agile, if we're doing that hypothesis testing, then there's no need if you have, a know-it-all in the middle of the room that decide. But I would advocate for the fact that at least having these inputs and taking them into consideration, maybe there's multiple outcomes and then that's the decision there. But again, us humans, the monkey brains, as I like to refer to, we don't don't do well with a lot of numbers. I mean, I can barely remember my own phone number, and then we're working with millions of data points. That becomes a problem. So then it's like what to include, what's the input, and then the directions you take. And again, carry over that testing, iteration, and adjustment in the agile methodology. It changes, but do it in due time, and you make sure to do that with the testing here. Agile flexibility. You have a hypothesis, you get a result. Maybe you do an MVP, and then you change directions. It's so much easier to do it a year before something becomes obsolete than right at the day where everything falls apart. Now I have my extra element, the secret or the prediction, as I say, where all of this is what we do now, and this is what we want to look into, the ethics in data processing, in data science, innovation, generally the ethics. So where most of us, at least here in the EU, we are very aware of the GDPR. And I also think they have a tendency to spread to multiple countries. It has its benefits. It's obviously not something we're against. But we all know that, especially in Europe or countries that adopt these rule sets, that it's a given. That's just how it is. It works pretty well. There's a lot of the processes need to be taken into consideration, but that's a given. But what about company data? What about patents? What about these elements that are professional or in this element? When we look at our data sets, when we work them, when we help our clients with innovation, we see that there's a power to make or break something. It's obvious that if you approach something with an algorithm or with a selection process that's supposed to be objective or is objective, then that actually determines the outcome of something. It could guide the success, identifying technology to work with. If you have a very large player within the industry, they will actually push that. So that then leads to the point where I suggest, or I see the future in data is transparent. It's looking back at that black box. It's very easy to run an algorithm. It's not easy, but it's easy to run. It's easier sometimes to run an algorithm that takes any means necessary to predict an outcome and has a high accuracy. But if that's a black box, if that's impossible to see any transparency within, it's not only uncomfortable to work with, it's also something where we can't really catch those, biases that always show up in algorithms, because again, they are designed by us humans, and sometimes we make those mistakes. We are biased as well. And if we can't catch that, if we can't work with that, we end up having those issues. So that's where I see the transparency. Not only personal data works well, you need to be able to know why your credit score has been chosen as it is. Seems fair. But if you choose to work with a technology, or if you prioritize a certain trend or consumer behavior, even though it's based on anonymized data and it's not really applied to anything, that's actually where I see the transparency becoming either pushed by the consumers, regulators, or the competitors. But one of the three, maybe all of them, all of a sudden will pick that up and say, hey, this is actually something where some value to gain. And then if we want to talk about the main takeaways, again, if you just jumped in now, then hopefully this will help you catch up. Unknown unknowns is a big thing in innovation. It's a big thing when working with data science, for that matter, or this process, the data-driven element. We need to open up and be, have the option to catch something we're not aware of. And then hypothesis-driven is something I would advocate for the rest of my life. I say, prove me wrong, please. But that's what you need to approach. You need to go out to something. You need to apply an algorithm, a business model, a suggestion, all this stuff with the idea, or with the question almost, prove me wrong. because if people can't, then you actually have something. It's uncomfortable, but it's necessary. Data, and more data. Obviously, I think I mentioned data just as much as I mentioned the monkey brain in this presentation. It's the key. Infrastructure and the approach, it's something you need to decide on. Sometimes the sooner than better, and sometimes you can design yourself out of the fact that there might be the needs to change halfway through. Again, microservices is something that I see more and more, and I would recommend in most scenarios. Not that it's always the best. And then the strategy, that gut feeling, it works in the beginning, but it cannot be the main foundation of the choice of strategy. In the end, I say ethics and transparency. I see that as a competitive advantage, not only in personal data, but in all data. Thank you very much for listening.